So we're now going to start talking about yet another concurrency model in Java called the Executor framework. And we're going to talk about the Executor framework. As you can see, there's a lot of moving parts to the Executor framework. By the time we're done with the entire course, we will have covered pretty much everything you see here, although we won't try to do that all in one fell swoop. We'll kind of break it up into different chunks. And as you will see, the assignments you'll be doing relate to the different chunks we're talking about at different points in time. So the Executor framework provides a lot of classes, a lot of interfaces, and basically what it does at a very high level is it decouples the creation and management of threads from the rest of the logic of the application. So that's really what the Executor framework does in a nutshell. So you don't have to think as much about threading. You're letting the framework do the bulk of it for you. And another key thing we'll talk about is it also provides a bunch of thread pools. There's a utility class. I'll remind you in a second what a utilities class is, that is used to get access to a lot of the capabilities that are part of the Java Executor framework. And it does it through a whole pile of factory methods that we'll talk about in a second. What is a utility class? A utility class is a class in Java that's a final class. That means you can't subclass from it. It contains only static methods. It has no non-static state, so if it has any state whatsoever, it's static state. And it typically has a private constructor to make sure you don't define an instance of the class. If this was a language like C++, we would think of a utility class as something like a namespace. In C++, where you can have functions that are not associated with a given class, you can put them into what's called a namespace. And the executor's class is kind of a namespace. So it's just used as a way to wrap a class name around a bunch of methods or functions, really. But you don't make instances of this class. You just use it to get access to these factory methods. There's a bunch of different factory methods here that do many things. We're going to focus primarily on the factory methods that are used to create various types of thread pools. And the next assignment is all about thread pools, as you can imagine. What is a thread pool? We'll talk a lot about thread pools in just a second, but at a high level, it's a pool of threads, as the name implies, that can be used to execute one-way or two-way tasks concurrently on multiple processor cores. And we'll talk in a moment about what a one-way task is. They use runnables. We'll talk in a moment about what two-way tasks are. They use callables. And we'll talk about what these tasks do and how they're mapped onto the underlying threads in the thread pool. A task is essentially a logical unit of work that ideally doesn't depend on the state, result, or side effects of other tasks. So if you play your cards right and you set your tasks up so they don't depend on anything else, that leads to what's called embarrassingly parallel program designs. And embarrassingly parallel, as we've talked about before, is sort of an ideal goal of concurrent or parallel programs because everything can run on different processor cores without having to worry about synchronizing or interacting or coordinating in any way, shape, or form, which is good. So that's a really quick high-level view of the Executor Service Framework. We will, of course, go into this in a lot more detail here momentarily.